Okay, so for example 3, we have a given coal-fired steam boiler which uses this 3,000 kilogram of coal per hour. The required for combustion is 15.5, so that is the air-fuel ratio with a barometric pressure of 98.20. The flue gas has a temperature of 20 to 85 degrees Celsius with a molecular weight of 30, assuming an ash loss of 11% and allowable gas velocity of 77.5 liter per second. Find the diameter of the chimney. Okay, so we don't have anything to balance. So everything is in terms of the mass already. So you can imagine your combustion chamber to have an input of the mass of the fuel. Okay, and then you have the input, which is the mass of the air. Okay, and then the flue gas. No? So you have the gaseous products, no? The flue gas. And since we have a given here, which is the ash loss, we also have an ash loss of 11%. So that what that basically means is that if you have 100 kilograms of fuel, 11% of that will become an ash. No? So per 100 kilogram, you have 11 kilograms of ash. Okay, so we can imagine if this is a mass balance. No? So if this is the combustion chamber, then the mass of the going in, no, going into the control volume is equal to the mass going outside of the control volume. No? Okay, so we don't have everything given here. We only have the air fuel ratio, no? And the mass of the coal or the fuel. The mass of the ash is not really given, but only the ash loss. No? But we can actually make this work if we can divide this. No? We can divide this actually by the mass of what? No? We can divide this by the mass of the fuel. So that this will become 1. So MF over MF. This will be just 1. And then we have mass over mass. No? So as you can see, what is this? No? This is the air fuel ratio, which is also this one. And then equals to, so we have the mass of the flue gas per mass of the fuel, and then you have plus mass of the ash per mass of the mass na pati, no? Mass of the fuel. So we have this given, no? We can find for this, no? So we want to find them to be able to find the diameter, we can maybe use the continuity equation wherein the mass is equal to the volume times the density. Or in other words, you have the area. So the area times the velocity and then the density. So the average velocity and the area. So to get this, you need to find the mass of the flue gas. No? The mass of the flue gas times area, which is pi over 4 t squared, and then the velocity. Actually, you can remove the bar and then the density. So we need to find the mass of the flue gas. So this is given. So we need to find this, but we can find this. We can find this, no? The density and the mass of the flue gas. Anyways, so for the ash loss, this is actually given, no? So this is actually 0.11%, no? So basically, if you say ash loss, how much ash, no, per mass of the fuel? So the mass of the ash per mass of the fuel. Okay, so if they say this is 11%, so again, 100 kilograms, you have 100 kilograms of fuel, 11% of that will become an ash, or in other words, that is also the ratio here. So we can find MFG, the mass of the flue gas per fuel, that is equal to, so we can transpose everything to the just a little bit of algebra here, no? So 1 plus 15.5, so this is the air fuel ratio. And then you transpose this to the other side, no? So this will become negative. So minus 0.11, which is the ash loss. So the answer here for the MFG, mass of the flue gas for the mass of fuel, is, I think I'll use a calculator, no? So 16.5 na lang, no? Minus 0.11. So this will be 16.39. 16.39. So what is the unit? The unit should be the mass of the flue gas or kilogram of flue gas per kilogram of fuel. So basically, if we have this, we can multiply this, no? So to find the mass of the flue gas, no, we can just multiply 16.39, which is in terms of kilogram flue gas per kilogram of fuel, no? Multiplied by the mass of the fuel, which is 300 kilogram, 3,000 kilogram, no, of coal per hour lang pala, no, per hour. So the fuel is also coal. We can just write here kilogram of fuel. We can cancel this out. The answer here is this. So the mass flow rate is equal to this. So this is very large. This since this is per hour, 16.39 times 3,000. So 49,170. 170. Sorry, not this one. Kilogram of flue gas per hour. Okay. So now that we have the mass flow rate, we now want to find the density, no? So the density is what we want to know. To know the density, we have, no, the formula is just PV MRT, but we know that the density here, if we do some algebra, so we have P over RT, no? So the pressure is given, barometric pressure, we have the temperature given. The R is not given, but the R can be found using the universal gas constant, no, and the molecular weight. So the gas constant 8.3143 over the molecular weight of where's the molecular weight of 30, you can get the R. So the R here is 8.3143 all over 30. So 0.2771, no? 0.2771. That is in kilojoule per kilogram Kelvin. So the density here can be found. So you have 98.20 kPa, no? Over 0.2771. So kilojoule per kilogram Kelvin. And the temperature of 285. So don't forget to add 273 since we need it to be an absolute temperature, no? Since this is in Kelvin. So the final answer for the density only, 98.2 and then 0.2771 times 285 plus 273. So the final answer is 6351. 0.6351 kilogram per cubic meter the density, no? Isn't that pretty low? This is pretty low, no? The usual air is 1.2, no? The standard air. Anyways, we can solve for this, no, already. So the mass flow rate is 49. So using this formula, guys, no? So you have 49,170 kilogram of flue gas per hour. We should convert this into per second, right? So how many hours per second? So R, 1 hour is 36 seconds, no? So just a conversion, no? Conversion here. And then you have pi over 4 d squared. The velocity is 7.5 meters per second. And then you have the density 0.63 what is that, 6351, so kilogram per cubic meter. You can do a unit analysis and you can see that this will be square meter, no, the remaining unit, no, so this will be in meters, so that the diameter can be solved, no. I'll just do this quick, no, but you can do some algebra as well. So I'll just do this. So pi over 4 and then times 7.5 times 0.6351, and then find the square root, no? Square root of ants. Oh, so the answer is 1.91, or 1.911 meters. So that is quite big, no? The chimney is about 2 persons wide, no? That's a big chimney. So that's it. Thank you, guys.